To summarize, we have done two things. First one, to take care of the relationship between the categorical dependent variable and the independent variable, we went for sigmoid function because we cannot use a ordinary least square. Now, what is the problem with the sigmoid function? I cannot establish relationship between the dependent variable and independent variable, meaning that per unit change in x will produce what kind of change in y. I cannot clearly establish a relationship because it's a sigmoid function. There is no linearity between the dependent variable and independent variable, and hence I went for something called as logic transformation. Right? It's so often confusing when you are reading the logistic regression. What is a sigmoid when it is used? Why we are going for other transformation? So there is a reason for that. So sigmoid functions takes care of establishing a relationship between the independent variable and categorical dependent variable. But after establishing the relationship, it is only a problem half solved because I could not able to interpret the relationship between the dependent variable and independent variable, and hence I need some transformation. That's where logic transformation comes into play in terms of establishing a generalized linear relationship between the dependent and independent variable. Now, with this at the back, we will further do. Why do we take all the trouble in doing the transformation from probability to log of odds? If you look at it, the sigmoid function gave answer in terms of probability, that is y is equal to 1, that is probability of the success class. Right? Now, from probability we went for logic transformation, that means from probability we went for odds transformation. Why we need to do that? This is the answer. So this, if you look at it, this is a probability, and this is the LHS of it in terms of sigmoid function. From this we have converted into this, that is ln of this, which is basically your logic function, and then if you look at this, the RHS looks like a linear relationship. Why we did this? The problem here is, the one reason is that it is usually difficult to model a variable which has restricted range. What do you mean by restricted range? If you look at it, the probability value has to be between 0 and 1. So that means the range for probability is always between 0 and 1. That is basically a restricted range. In order to overcome this restricted range problem, so we are going from the sigmoid function to logic function. Now the odds can vary from any value, right? So the odds can vary to any value, but the probability will always remain between 0 to 1, right? This is called restricted range problem. So for this condition we need to transfer this, we need to take all the difficulty in terms of transforming this probability into log of odds. So before moving on, let us spend some time in terms of understanding what is odds, what is probability, how these two are related, right? So we keep on hearing about this. Let us take an example to understand how to calculate odds. So odds is nothing but probability divided by 1 minus probability. Example, if the probability value is given is 0.75, then how do I get the odds value? Then substituting this, odds is equal to probability divided by 1 minus probability, I will get 0.75 divided by 1 minus 0.75, I will get the ratio of 3 by 1, which is represented as 3:1, right? So odds are usually represented in terms of ratio, right? So 3:1, right? So here we can say this is a winning odd and this is a losing odd. The odds of winning is 3 times more than losing, right? So that is basically, that is odds in favor of winning is 3:1, we can call it. This is a relationship between odds and probability. If the odds value is given, how to get the probability? In this case, probability value is given, how to get the odds? Let us also understand, if the odds value is given, how to get the probability. So what is the relationship of probability to odds is, probability is equal to odds divided by 1 plus odds, right? So this is positive here, this is negative here, that is one easy way to remember. So probability is equal to odds divided by 1 plus odds. If the odds values are given, let us say 3:1, then how do I get the probability? Then probability is odds, which is 3 by 1, divided by 1 plus odds, that is 1 plus 3 by 1, then you get the value of 0.75. right. So, if you look at this, if probability value is given, which is 0.75, then I get the odds value, which is 3:1. If the odds value is given, then I can get the probability value, right. This is the relationship between odds and probability. Sigmoid function gives a probability, that probability we are converting into odds, and that is how we get the odds. Then further we need to reverse back into probability, and hence it is essential to understand the relationship between how to convert odds to probability and probability to odds. Now, moving further, same question, why do we take all the trouble doing the transformation from probability to log of odds? The simple answer is to overcome the restricted range probability which is associated with the probability, which is probability value can only range between 0 and 1. If you take an Excel and then put some probability values, right. So, let us say in terms of ascending order and descending order. Ascending order starting from, let us say, 0.11, right. So, you can go to 0.01, so on and so forth also, and then increase incrementally in terms of 0.01 until you reaches, let us say, 0.99, right, and then convert that into odds. Probability value is given. What is the odds? Odds is equal to probability divided by 1 minus probability, right. So, let we have seen here. So, what I did, I put these values as a probability and then I converted into odds using this equation called probability divided by 1 minus probability. That is, how do I get 0.12, which is 0.11 divided by 0.11 divided by 1 minus 0.11. If you solve this, you will get 0.12, right. So, this is your odds. Now, what I did, I taken a ln of odds, that is ln of 0.12, which gives you minus 2.09. Now, see this, probability value ranges from 0 to 1, whereas the ln of odds value can go to minus infinity to plus infinity, right. So, if you look at it, I have overcome the restricted range problem associated with the probability of 0 and 1 to minus infinity to plus infinity, right. So, in this case, for this probability, if you draw a scatter plot diagram and connect the dots, so you will get something like this, right. As you can see this, the value can range from minus to plus, which is your natural logarithm of odds, because this is the graph of natural logarithm of odds. So, the natural logarithm of odds can go anywhere between minus infinity to plus infinity, but at the end of it, the probability value for that respective natural of odds can never go between go beyond 0 to 1, right. So, 0 to 1 as a restricted range probability I am overcoming by means of transferring to natural logarithm of odds, right. So, you can try it in Excel, you will get something like this. So, this is the problem that logit transformation is fixing, overcoming the restricted range probability. Now, this is what we have seen, and some other things are related with it. It maps the probability ranging between 0 to 1 to log of odds ranging from negative infinity to positive infinity. That is what we discussed now. And also another reason is that among all the infinitely many choices of transformation, right. So, you might have ask a question, why only logit transformation, right. So, why ln of odds, right, natural logarithm of odds, any other transformation also we can use it, right. Yes, we can use it, but log of odds is one of the easiest to understand and interpret, right, interpret in terms of relationship between the dependent variable and independent variable, and hence this logit transformation qualifies and makes our job easier in terms of interpreting the relationship between the dependent and independent variable, and hence logistic regression become a success.